So we've been learning about how to write equations of lines, and we have some new types of problems to look at. One of them has to do with parallel lines. This first thing talks about the definition of parallel lines in a coordinate plane. I want you to think of parallel lines as train tracks. Train tracks can never cross or else the train's in trouble, and here's kind of a movable train track, but you can kind of see that those two are running parallel to each other. Now, in a line form, parallel lines really just mean this. We can use indicators of arrows in the same direction to talk about the same direction, but no matter where the parallel lines are positioned, they have the same slope, meaning that up over is the same for the two different lines, even though they're in two different spots. And I'm going to show you for just a brief second what this looks like on a graph here. Let's go to this one. This is a graph, and on the left here you can see I'm graphing y equals mx plus b, and I've stuck sliders in for m and for b. B is the y-intercept, so as I slide this left and right, the line is moving up and down depending on where the y-intercept is. And you can see that kind of the y-intercept's right there, but you can see as I move it up and down, that y-intercept is changing, and it's changing to be exactly what that b is. Now, if I change this m, I'm changing the slope. You can see the line twist and turn around that. So what I'm going to do for my second y equals mx plus b, I'm going to do another one, y equals mx plus, but instead of b, I'm going to put a different thing. I'm going to put c. I'm going to create a slider for that. Now, c is a different number than b, but you can see that no matter what it changes, no matter how it looks, it has a different position most of the time, but it's the same slope. And I know that because m is the same in both. Here's the slope of both of them, and if I change m, I can see it's changing the slopes of both these lines, but since they're always the same slope, they're going to be parallel. Now, as m gets really negative or really positive, they can come really close to each other, but they're never going to be the same. They always have the same slope. So, moving back over here, parallel lines, I'm just going to write this, parallel lines have the same slope. They have different y-intercepts. So this first question says to write an equation in slope-intercept form of the line that passes through the given point and is parallel to the graph of each equation. So this right here is the given point. And this right here is the equation that it refers to. So I want it to pass through this, but I want it to have the same slope as the 5x plus 3y equals 9. Well, to figure out what the slope of 5x plus 3y equals 9 is, I have to first put it into slope-intercept form. I can't figure out the slope easily from that. So I'm going to subtract 5x from both sides. 5x plus 3y equals 9. If I subtract 5x from both sides, I'm going to get 3y is equal to negative 5x plus 9. Then if I divide both sides by 3, I get y is equal to negative 5/3 x plus 3. Graphing this one, just to see what it looks like. I don't really care about this line, but I want just to graph it. I've got plus 3, and then down 5, right 3. And that's down 5, right 3 again. And that would be up 5 and left 3. Now, I'm going to keep this very faint because this is not the line that I'm looking at. I want this new line. I want to generate a new line. So I'm going to steal the slope from this one, steal this point, and basically when I say it's parallel to this line I just drew, I want it to have a slope of negative 5/3 and a point of 6 negative 3. Well, to do point and slope, I need to use point-slope form. So I'm going to go y minus y1 equals slope times x minus x1, or y minus a negative 3, y plus 3 is equal to negative 5/3 x minus 6. It wants it in slope-intercept form, so I'm going to distribute the negative 5/3. negative 5/3 x plus, this would be plus 10, and then subtract 3. Y is equal to negative 5/3 x plus 7. This is my answer. This is the correct new line. It has a different position based on that new point it wanted me to graph. And then I can check to make sure I'm accurate. I'm going to check by plotting this line on the graph up here. Plus 7 would put me right here. Down 5, right 3. Down 5, right 3. Down 5, right 3. So yes, it does indeed looks like it goes the same slope as the other one. It's never crossing. Let me try to draw that just a little bit more correctly. There we go. Down 5, right 3. Down 5. 1, 2, 3, 4, 5. Oh, that was a little bit off. That didn't look quite right. Right 3. Down 5, right 3. There we go. That looks far better. And I also want to check that it actually does pass through 6, negative 3. So 1, 2, 3, 4, 5, 6. 1, 2, 3. Yep, that's the point 6, negative 3. So it did pass through there. So again, my solution is just this equation. But that equation corresponds to the green line. Okay, let's try this one. We're going to figure out the slope of this line first. 3x minus 2y is equal to 7. I'm going to subtract 3x from both sides. And I get negative 2y is equal to negative 3x plus 7. I'm going to divide both sides by negative 2. So I get y is equal to 3 halves x minus 7 halves. And I'm going to graph that on here. Well, minus 7 halves is negative 3.5, and that's right here. And a slope of 3 halves is up 3, right 2. And that's going to pass through this point. So if I kind of graph the whole thing based on this point, and I go up 3, right 2, up 3, right 2, and down 3, left 2, and then put all these little points in here, I should be able to get a good image of what this line is going to look like. Now, we're going to steal the slope, and we're going to steal this point, and we're going to plug them into point-slope form. Y minus 1 is equal to 3 halves times the quantity x minus a negative 3. Point-slope form. Y minus 1 is equal to 3 halves x plus 9 halves. And then I'm going to add 1 to both sides, and I get y is equal to 3 halves x plus 11 halves. I'm going to graph that on here. 11 halves is the same as 5.5. So I'm going to go up 5.5, which will be right here. Let's do that in red to make it match. Up 3, right 2 puts me right there, and directly in between these 2 points is this point right here. That's a nice little even crosshair one. So I can't go up 3, right 2, but I can go down 3, left 2. I'm going to keep doing that. Down 3, left 2. And then I'm going to put all the little half points in between, like right here, and right here, and right here, and right here. And then I'm going to connect all these. Looks pretty parallel to me. Yep, looks pretty good. And then let's just make sure that we pass through negative 3, 1. Yep, that's right here. This is the point negative 3, 1. So my answer looks pretty good. We have a second kind of line, perpendicular lines. This one's a little bit more tricky. Two lines are perpendicular, and this is the symbol for perpendicular. This thing right here makes it so we don't have to write that word out. Two lines are perpendicular. Moving back up here, by the way, the symbol for parallel is what you see right here. It's literally that symbol. Sometimes people write it like that just to kind of make it, but the symbol for perpendicular is a little bit more easily used. Two lines are perpendicular if their slopes multiply to negative 1. And what this means is if m1 is a slope and m2 is a perpendicular slope, then m1 is equal to the opposite of 1 over m2. Okay, this is a little bit tricky. So here's what I kind of think about with this. Perpendicular lines have opposite reciprocal slopes. Opposite means make negative positive, make positive negative, and reciprocal means flip. It means flip the fraction. And we're going to practice this here. So, the next equations or steps say write an equation in slope-intercept form of the line that passes through this point, 2, negative 3, and is perpendicular to this graph. So like before, we're going to take this and we're going to solve it to slope-intercept form. I'm going to subtract 2x from both sides. 5y is equal to negative 2x minus 10. Divide by 5. And I get y is equal to negative 2/5 x minus 2. Now, I'm going to use this notation. Underneath here, I'm going to write the slope is negative 2/5. So the perpendicular slope is the opposite reciprocal of this. The opposite of 2/5 is, or negative 2/5 is positive 2/5, and the reciprocal would be 5 over 2. So I flip the fraction and I change the sign. And now I'm going to steal this slope and this point and make my new line. My new line would use point slope form. Y minus negative 3 is equal to 5/2 times x minus 2, or y plus 3 is equal to 5/2 x minus 5. Subtract 3 from both sides, and I get y is equal to 5/2 x minus 8. Now, let's graph both of these just to kind of confirm that they are in fact perpendicular lines. We're going to do the first one. I'm going to throw that on here, so minus 2, negative 2/5 is down to right 5, down to right 5, 2, 3, 4, 5, up to left 5. Oops. And let's put some half points down so I can connect this pretty smoothly. And then let's graph this one. Y is equal to 5/2 x minus 8. So down 8, then up 5, right 2, up 5, right 2. Put some half points down. And then graph it. Okay, those look pretty perpendicular to me. They cross at right angles. And if I check that it crosses to negative 3, let's see, I want to go over 2, down 3. Nope, I went down 7. Got to redo this line. 1, 2, 3, 4, 5, 6, 7, 8. There we go. That's 8. Now, up 5 over 2. Up 5 over 2. Up 5 over 2. Put these points in. Connect. And now I've hit this point 2, negative 3. And my final answer is this equation right here. It's not anything else other than that equation. It's the equation of the line that was perpendicular to the first line but passes through 2, negative 3. In this next one, I'm going to take this equation. I'm going to solve it for y. So I'm going to subtract 6x from both sides. Then I'm going to divide by negative 2. So I get y is equal to 3x minus 3/2. And I'm going to steal the slope. This slope is 3. The reciprocal of 3 is 1/3, and I need to change the sign, negative 1/3. That is my perpendicular slope, and that's the one I'm going to steal along with this point. Y minus 1 is equal to negative 1/3 x minus 4. Distribute the negative 1/3, and I get plus 4/3. Add 1 to both sides, and I get y is equal to negative 1/3 x plus 7/3. Okay. I promised you we wouldn't graph thirds, so we're not going to graph this one, but I'm going to circle that and be confident that I've answered the question of writing the equation. The graph is just here to help us. If I were to want to graph that, what I would recommend doing is graphing it with a t-chart. Because 7/3 is not a clean point, I want to try to find a good starting point. So what I would graph is, instead of starting at the y-intercept of 0, 7/3, I might plug in 1. And if I plug in 1, I get negative 1/3 plus 7/3, which is 6/3, or 2. And so 1, 2 is a good point, and I would probably start there. Then do the slope of negative 1/3 from that point, and up 1 left 3, and up 1 left 3, and up 1 left 3. Maybe put some half points down to guide drawing this. Those all look good. And then as I connect that, this is my final answer line. But I'm graphing it just to show you that we could graph something like that. It's just, even if it's not very clean. And then now I'm going to graph the original one just to confirm that we do have a perpendicular line. Negative 3/2 is right here. Up 3 over 1. Up 3 over 1. Up 3 over 1. Down 3 left 1. Down 3 left 1. So not some easy points to graph, we can still do it. And we can see that yes, those are right angles to each other. So my equation looks good. Now, number 5 says to determine if they're parallel, perpendicular, or neither, and all we have to do is compare the slopes. These should be a little quick problems to do. The first one is already in slope-intercept form, so its slope is negative 2. The second one, I need to change it to slope-intercept form by subtracting 2x from both sides. Y equals negative 2x plus 23. That slope is negative 2. They're the same slope, so they are parallel. In this one, this slope is negative 5, and this slope is 5. They're both in slope-intercept form. It looks like those should be something, but the perpendicular slope for this one would be positive 1/5, and that's not what this is. And the perpendicular slope for this one would be negative 1/5. So since these don't match and these don't match, these are neither. They're neither the same nor are they opposite reciprocals. Number 7, my slope here is 0.6, which is the same as 3/5. And in the second part, I'm going to divide by 3 and get negative 5/3 x plus 10. And that slope is negative 5/3. 3/5 and negative 5/3 are opposite reciprocals, so they are perpendicular. Finally, in number 8, I'm going to subtract, and I get y is equal to negative 11. That slope is 0 because it's a y equals line. Y equals lines are horizontal, and all horizontal lines have a slope equal to 0. In this one, if I subtract y from both sides, I get x equals 7. That slope is undefined. Undefined represents vertical lines. So I know that we don't really think about the math with these, but this is a horizontal line and this is a vertical line. And clearly horizontal and vertical lines are perpendicular to each other. Finally, for our last few problems, we just have no graph, and we're just going to go with the words. It wants an equation in slope-intercept form. This first one says it passes through negative 5, 3 and is perpendicular to the x-axis. Let's draw a grid and see which one the x-axis is. It is the horizontal one. If it is perpendicular to a horizontal axis, it looks like this. That means it must be vertical. So vertical lines are x equals equations, and the x equals here would be negative 5. There really isn't any other work you have to show for that. Since I'm a visual learner, I would probably draw or sketch an axis and just try to figure out the direction that it's talking about. Remember, vertical lines, x equals equations, undefined slope. Horizontal lines, y equals equations, slope is equal to 0. Number 10 says it's parallel to the graph of y equals 5/4 x minus 3, and it passes through the origin. This is tricky because the origin just has coordinates of 0, 0. If it's parallel to this first graph, we can steal its slope. Parallel means we're going to keep the same slope. So there's my slope and there's my point. I could use point-slope form if I wanted to, or I could use slope-intercept form because if it passes through the origin is the y-intercept. Let's just use point-slope form to keep in that habit. Y minus 0 is equal to 5/4 times x minus 0. And this would just be y is equal to 5/4 x. Number 11, it says an x-intercept of 3. And I'm going to stop right there and just write the ordered pair 3, 0. Perpendicular to this graph here. Well, to do that, we're going to want to put that equation into slope-intercept form. Subtract 5x, negative 3y is equal to negative 5x plus 2. Divide by negative 3, y is equal to 5/3 x minus 2/3. Then I'm going to take this slope, steal it. M is equal to 5/3, but it says perpendicular, so I have to change it. The perpendicular slope is the opposite reciprocal. It's positive, so we make it negative. It's 5/3, so we make it 3/5. Finally, once I have a point and a slope, I'm going to use point-slope form. Y minus 0 is equal to negative 3/5 times the quantity x minus 3. Distribute the negative 3/5, and I get negative 3/5 x plus 9/5. Last one, y-intercept of negative 6. I'm going to stop right there and put 0, negative 6, and parallel to the graph of x minus 3y is equal to 8. If I subtract x from both sides, I get negative x plus 8, and if I divide by negative 3, I get 1/3 x minus 8/3. Steal this slope. This slope is positive 1/3, and I'm going to keep it because it's parallel, so I get to use that. Let's do point-slope form again, just because we've been doing it all the time. Y minus a negative 6, or y plus 6, is equal to 1/3 times the quantity x minus 0. Or y plus 6 is equal to 1/3 x, or y is equal to 1/3 x minus 6. Now, if you'd gone straight ahead and used slope-intercept form, you can see you'll get the same thing. We can only do that because I have the y-intercept. So I can just go right into 1/3 x, that is the y-intercept, minus 6.